Hi, how are you? Okay, today I'm going to correct some exercises for you. This is these exercises are on page number, yes, this page 146. Okay, um, number 18. Calculate your mass and your weight on Earth, Moon, Mars, Jupiter, and the Sun. First, we have to copy we have to copy the gravities on every planet. Okay? Okay. Now you have to calculate your mass. How do you do it? With a scale. So, for example, imagine your mass. You have to change. Your mass is, imagine, I don't know, 80 kilograms. Imagine your mass is 50 or I don't know 60 kilograms. So you have to do the same, but changing this mass for your mass. Okay. So if this is your mass taken with a scale, okay, our on Earth weight on Earth is the mass multiplied by the gravity on Earth. The gravity on Earth is not here, but we know that it is 9.81. So it is 80 multiplied by 9.81. Okay. Imagine you had this mass, but um, you have to change on the exercises 80 this mass for your mass. Okay. So the weight will be different. Okay. 80 multiplied by is 70, 80, so 780, 84 newtons. Okay, 80, yes, point 0.8. Sorry. Okay, now your weight, for example, on the moon, is the mass multiplied by the gravity on the moon. It is 80 because the mass is the same. Because the mass is the amount of matter you have, so the mass is the same on every planet. And the gravity, the acceleration of gravity or the gravitational acceleration is 1.6. So the weight of the same body would be 80 multiplied by 1.6. It is 128 newtons. So that's why, for example, if you watch TV and see an astronaut jumping, for example, you can see that the astronaut can jump very high because with a little effort, because the gravity is very low on the moon. Now, the gravity on Mars is the weight on Mars is the mass divided multiplied by the gravity on Mars is equal to 80. So the body is always the same body. The mass is the same always. It's always the same, sorry. 3.7. It is smaller, can you see? Smaller than on Earth. So on Mars, we can jump higher with a lower effort than on Earth here. Okay. Okay. So it is 18 multiplied by 3.7 is equal to 296 Newton. Next, the weight on Jupiter, and then the weight on the Sun. So you have to calculate both. M is equal multiplied by the gravity on Jupiter. Take into account, notice that you have a big gravity on Jupiter. Why? Because the mass of Jupiter is much bigger than the mass of Earth. Okay, because Jupiter is a big planet and with a bigger mass, a very big mass. Okay, much bigger than the one of Earth. Okay, so 80 multiplied by 22.9. So it's 80 multiplied by 22.9 is equal to 180. Yes, this is the number. So your weight on Jupiter, if you were to Jupiter, okay, you will wait a lot, and your legs maybe couldn't move you. Okay, maybe you wouldn't have the enough force for moving on Jupiter. Okay, okay, because your muscles, musculars, are not so strong so as to move on Jupiter, to walk on Jupiter, because the weight is very high. Okay, the gravity is much higher than the gravity on Earth, and we are used to the gravity on Earth. Our muscles, muscular, are used to move our body on the Earth, but not on Jupiter. Okay, and on the Sun, imagine it is much bigger. Is 80 multiplied by 274. So it is 80 multiplied by 274 is equal to 21,920 newtons. So it is impossible for you to walk on the Sun. Okay, maybe maybe if you were on the Sun, you will be flattered, okay, aplastados, or pushed against the surface of the Sun. Okay, maybe you here Jupiter on or on the Sun, you couldn't. Maybe you couldn't walk on them because the weight is your weight would be very high. Okay. Okay. Number 20. Okay. You don't have to do this. Well, you can try, but it is not necessary. Okay. I will do it here. Determine the gravity of a planet knowing that a mass of 5.3 kilograms weight, knowing that, yes, a mass of this weighs, sorry, the weight is 23.32 newtons. So we write the formula always. You know that you have to write the formula M multiplied by G. Now we know that the weight is 23.32. The mass is 5.3 multiplied by G. Okay, so G is equal to, we pass 5.3 to the other side, dividing, okay? Divided by 5.3. So let's do the operation. 23.32 divided by 5.3 is equal to G in this planet, on this planet, sorry, is 4.4. You can say meters per second square because G is an acceleration, or you can also write 4.4 Newton divided by meter. Sorry, by kilogram. Okay? Both units are the same. Okay? Because here, how do we know this? Because from here, if we write the units, for weight is Newton, for the mass is kilogram, and the units of G, if we can solve the units, despejar the units of G, we use these brackets for say we are writing the units. So the units of G are, if we divide Newton divided by kilogram. But we also can use meters per second square because G is an acceleration. Okay? So these are these two exercises. Now I will going to I will explain. I will explain the last part of the unit. Okay, and I will do these two exercises. Okay, the distance in the universe. You have to know. You probably know. You already probably know that the distances in the universe are very big, are very long, okay, very large. I don't know how to say that. They are big, huge, huge. Huge is inmensas, okay. Um, the distance in space are so large that working with kilometers is unviable, inviable. Inviable means that significa que inviable que no es útil usar los kilómetros porque son unidades, son distancias tan grandes que tendrías que usar millones, trillones, cuatrillones de kilómetros y entonces no es viable. Okay? So we use if we traveled, si viajáramos at the speed of light, okay, speed of light, okay, speed, wait a moment, speed of light, la velocidad de la luz is, we call it c, we don't write v, no, we use c, the speed of light is 300,000 kilometers per second. Can you imagine this quantity? 300,000 kilometers in 1 second. This is the speed of the light. Okay? Light speed. Okay? En español, para que os enteréis, c, llamamos c a la velocidad de la luz, no usamos v de velocidad, sino c, porque es una velocidad especial, es 300.000 kilómetros en cada segundo. 300.000 kilómetros por segundo. Es una barbaridad. ¿Os dais cuenta? 300.000 kilómetros en un segundo. This is the biggest speed that anybody can reach ever, okay? That was said by Einstein. Einstein said that this speed is the maximum speed that anybody can reach, okay? Einstein dijo que esta velocidad es la máxima que cualquier objeto puede conseguir. No se puede superar, ni siquiera alcanzar en algunos casos. Okay? So if we do conversion factors here, 1 kilometer is equal to 1,000 meters. Okay? Because I am passing it to the international system, it is 300 million meters per second. Okay, 300 millions. And this is, if we convert this to scientific notation, we put the comma here, so we have 3 times 10 to the power of 8 meters per second. Okay, this is the speed of light in the international system. 3 times 10 to the power of 8, okay, meters per second. Okay, although it is well known as 300,000 kilometers per second, okay. La conocemos como 300.000 kilómetros por segundo, but in the international system it is 3.0, okay. We can write 0.0 times 10 to the power of 8, okay. Okay, this is the speed of the light. So for measuring distances in the universe, we use the light time. The light time is a distance. Es, el año luz, bueno, okay, tiempo luz, okay, tiempo luz is the distance that light travels in one time. So in particular, we use light year. Okay, light year. Do you remember Toy Story? Buzz Lightyear. Okay, so 1 light year is a distance. Okay, 1 light year is, you can copy it, is the distance that light travels in 1 year. Sorry. Okay? So 1 light year, un año luz, is one distance. It is not a time, it is a distance. It is the distance that light travels in 1 year. Can you imagine? The velocity is 3 times 8, or this quantity, meters in 1 second. So let's calculate what is the distance that, remember, we had the velocity for a uniform linear motion, movimiento rectilíneo uniforme, which is the type of motion that light has. We wrote, do you remember, the velocity is x2 minus x1, do you remember, t2 minus t1, okay? So in this case, the velocity is c, because the light travels at a velocity of c, we know it is 3 times 10 to the power of 8, and this is the distance we want to calculate, and we have here 1 year as the time. Well, we can write here, wait a moment. Okay, so the distance, as you can remember, that this is the distance in 1 year, okay, in 1 year, traveled in 1 year is c multiply, if we pass this to the this side, multiplying the time. Okay, so the distance is 3 times 10 to the power of 8, which is C, multiplied by 1 year. 1 year. This is, wait a moment. This is meters per second, okay, multiplied by 1 year. Well, we write only y, just y, okay? So we can't, we have to convert 1 year to seconds, okay? We have to convert 1 year to seconds in order to cancel this with time, okay? But not now, not yet, okay? We have to first to pass 1 year to 2 seconds. And so 1 year is equal to 365 days. Okay, 1 day is 24 hours, and 1 hour is equal to three. Well, we can do it in 2 times. Is 60 minutes, and 1 minute is 60 seconds. So we cancel years, days, hours, and minutes. Okay, and at the end we have. Let's do the operation. We have to calculate this number multiplied by this number, by this number, and by this number. Okay, so it is 300. Wait a moment. 365 times 24 times 60 times 60 is equal to. Let's yes, I will convert it in. Okay, it is seconds, but in this case we have to we should we it is much better if we convert this to scientific notation. You can use the calculator if you don't remember. Formato de número 3, notación científica, yes, with 3 decimals. So it is more approximately 3.15 times 10 to the power of 7 seconds. These are the same, okay? So if we substitute 1 year by this quantity, 3 this time, okay, we can sell seconds, and we do this operation. So it is multiplied by 3 times 10 to the power of 8, and it is 9.46 times 10 to the power of 15 meters, okay, meters. Or it is also if we want to pass them to kilometers, okay, it is dividing by 1000. It is 9.46 times 10 to the power of 12 kilometers. So in 1 year, in 1 year, light travels a distance of this number. This number is, imagine, 9. I will write many zeros. Okay, so the comma is here, I have to pass the comma to jump the comma 12 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 here. So this is, sorry, I have to, okay, all these kilometers in 1 year, okay? All these kilometers in 1 year. So this is 1,000, this is million here, million, thousands of millions, millions of millions. So we have 9.46 billion kilometers in 1 year. So, and that's why we use as unit of distance in the universe the light year. So the light year is the same as all of these kilometers. Okay, is that okay? Do you understand? I recommend you to. I suggest you to review this video, uh, how I did it, this conversion. So one light year is equal to all these kilometers. So it is 9 billion, 9 million, 9.46 millions of kilometers in 1 year. Okay? So, okay. Um, so, for example, Andromeda, where is it? The galaxy of Andromeda. No. Yes. Oh, Alpha. Sorry. We will do now these two exercises. As you can see here, our nearest star, la más cercana, la estrella más cercana, Alpha Centauri, is 4.3 light years away. Okay, 4.3 light years. So this this star is at 4.3 times this number of kilometers. Okay, a huge distance, a very large distance. Okay, so here we have, you can see here, um, from light time we have the following unit of distance. A light year is defined as the distance that light travels in a year. It is equal to this number. Okay, it is the same except for the one because with my calculator I only took three numbers, okay? But there is one here, okay? It is not important. The important thing is this one, okay? The order of magnitude is 10 to the power of 12. It is so much, okay? So large distances, okay? So we use, remember, we use light year for measuring the distances in the universe. It is very important. We don't use kilometer or meters or centimeters. It is useless. Okay? It is a nonsense. It is a absurdo. Okay? So, for example, um, the moon is 384 1,400 kilometers from the Earth. How far away is it in light time? So, yes, we only have to calculate the time taken by light to come from the moon to the Earth. Okay, and imagine we have to do the same. Remember this? Okay, I will do it for you here. Don't worry. Wait a moment. Wait a moment. Here. Here. that one. Okay, this small. Okay, this is a solved example, but we are going to do it here without looking at the solution. Okay, so the distance, remember, x2 minus x1. So this is x2, the final distance, minus the initial position. Sorry, position. Final position minus initial position. Okay. Yes. Do you understand? Okay. This is the difference in x. Okay. So the distance is 380. Sorry. 384,400 kilometers. Okay. The speed of light, you have, sorry, speed of light, you have to remember this number. Um, yes, 8 meters per second. Okay? If we convert this to remember this number, where does this number come from? From here. You remember? Here. Okay? 300,000 kilometers per second. It is or is equal to this number in the international system. Okay, so now we have to pass this to the international system. Okay, we cancel kilometers and we have 1, 2, and 3. Okay, um, sorry, meters. And if we use scientific notation, you have to take to notice that this is the use of a scientific notation because it is useless again and viable, inviable to use these huge numbers. That's why we use scientific notation. It is much better to use this number than this one. It is useless to use this number to write 0, 0, 0, 0, 0. Okay, you have to use scientific notation, and that's why here we have 3.844 times 10 to the power of, tell me, the comma will be here at the end, so, and it is here now, it is here, 1, 2, 3, 4, 5, 6, 7, 8. So to the power of 8, okay? 8 meters. Okay, now we have to calculate the time taken by light. So C is equal to the distance divided by the time. We have to calculate the time. The time, do you remember how to solve the time from this formula, from this equation? Remember, the time taken goes to the other side, multiplying. Okay, and we have this. Okay, now C goes to the other side, and we have the time is equal to, okay, or simply you have to swap. Do you remember swap these two? I explained this to you during our lessons in school. But I don't remember if you remember it. Okay, so it is. Wait a moment. The distance divided by the speed of light. So the distance is from here 3.844 times 10 to the power of 8 meters, and the speed of light is 3 times 10 to the power of 8 meters per second. Okay, and now if we do this with a calculator, you will have 3.844 844 times 10 to the power of 8 divided by 3 times 10 to the power of 8. And it is 1.28 seconds. So light takes 1.28 seconds to travel from the moon to the earth. Okay, so we are when we look at the moon, when we see the moon, we are really watching what happened 1.28 seconds before. Do you understand? Lo voy a decir en español, a ver, para que os enteréis. La luz tarda en recorrer la distancia de la Tierra, de la Luna a la Tierra, a esta velocidad, la luz, porque es la luz, 1.28 segundos. ¿Qué quiere decir? Que tú cuando ves la Luna, cuando miras la Luna, cuando la ves, estás viendo lo que pasó en ella hace un segundo y 1,28 segundos. ¿Lo habéis entendido? For example, for sun, if you calculate the time taken by light to travel, time taken for the light to travel from the sun to the earth, I think it is 8 minutes. Okay, so the light you are using for reading, for seeing people, for seeing things, um, um, starting traveled, starting traveling, started traveling 8 minutes before. Okay, so wait a moment. I don't know if we have here this exercise. Ah, yes, it is here. Yes. Okay. So let's do these two exercises. I hope you have understood this. We have to do, where are they? These two exercises here. Okay. For example, the first one, 21. Okay, 21. The sun, it says, the sun is, I don't like this format for the numbers. I prefer using scientific notation because the distance, because this number is very difficult to use. Okay, so it is much better to use scientific notation. So 1 and this is what um, we this is why we really use scientific notation for. Okay, it is useful for these big numbers, so let's use it. Okay, don't write these numbers, but they are complicated and we can handle them, no podemos manejarlos. Okay, so it is 1 point times 10 to the power of, let's count. You can do it with the calculator, don't worry, with the calculator. 2, 4, 6 and 8 kilometers. Okay, so imagine this is the earth and this is the sun. Okay, and the distance between them, more or less, the distance between both surfaces, entre las dos superficies, is this. Okay, this distance. Okay, if the sun disappeared at 12 a.m., what will you observe for the following 10 minutes? Okay, imagine. Okay, discuss your answer with a partner. Yes, dice en español, si el sol desapareció a las 12, ¿qué observarías durante los siguientes 10 minutos? ¿Mm? ¿Lo pensáis? Un momentito, ¿eh? So, sorry, I had to go to speak to my son, okay? Okay, we were speaking about this exercise. So this is the distance covered by light, covered, okay, traveled, covered by light from the sun to the earth, okay? The sun disappeared at 12 a.m., okay? Imagine. What would you observe for the following 10 minutes? Okay, so we have to calculate. Let's calculate the time taken by light for the light to travel to cover this distance. Okay, so you remember C is equal to, don't write B. Okay, don't write B because we are speaking about the the speed of light. Okay, so we have the distance covered by divided by the time taken. Remember, distance covered or traveled, time taken. Okay, distance covered or traveled by the time taken. Okay, so we have to calculate the time. The time is equal to, remember, we swap these two variables. Okay, it is equal to the distance variable, no? Yes, variable, yes, I think so. So let's pass first kilometers to meters, okay? I don't have the space here. And if you do this operation, you will have with the calculator. I don't need the calculator, to the power of 11 meters, because remember this, or notice that it is 1000 is 1 time 10 to the power of 3. So if we multiply here by 1 time times 10 to the power of 3 here, okay, we have 1 multiplied by this number. It is the same number. And we have 10 to the power of 8 multiplied by 10 to the power of 3. We have, so we have this 10 to the power of 8 multiplied by 10 to the power of 3. Remember the powers, las potencias, the same base, la misma base, and different exponents, and multiply. So we write plus 3, okay? So it is equal to 10 to the power of 11, okay? Do you understand? But don't worry, no worries at all. You can use the calculator for multiplying these numbers, okay? Don't worry. I just was giving you some information, I think it is useful information for you. So the distance taken is 1.496 times to the power of 11 divided by 3 times 10 to the power of 8, which is the speed of light. So let's do the operation. 1.496 times 10 to the power of 11, sorry. Yes, divided by, uh, wait a moment, to the power of 11, yes, divided by 3 times 10 to the power of 8. It is 4.99 to the power of 2. And what are these? What are the units here? So let's take into account that it is meter. This is meters, okay? And here we have meters per second. So remember or notice that we cancel meters and seconds go to the numerator, okay? So we have seconds. And if we want to convert this to normal notation, we have 499 seconds. If we take out the scientific notation, take the scientific notation out. So imagine this is 499 seconds, and now let's pass it to minutes to have an idea of how much time um, the light to have an idea of how much time the light takes to travel from the sun to the earth. So 60 seconds is equal to 1 minute. So notice that how important is to know conversion factors and scientific notation. Okay, we studied it during the first unit of this course, but it is so important for science that you have to get used to conversion factors and scientific notation. It is very important. Okay, so it is. Let me see. Divided by 60, it is equal to 8.31 minutes. Okay, so the light takes 8.3 minutes to travel from the sun to the earth. So if the sun disappeared at 12 a.m., we will keep watching it, okay, until we will keep watching the sun until 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 12, sorry, yes, 12, uh, yes, 12:08 minutes and a little bit more, okay? Okay, so we will keep on watching the sun 8.3 minutes later than the sun has disappeared, okay? Lo voy a explicar en español, mirad. Es que no sé si os estáis enterando con el inglés y tal, no sé, que también, bueno. A ver, la distancia es esta. Me la dice, voy a hacer un resumen, ¿vale? Me lo dice aquí. Yo lo paso a notación científica porque es mucho más manejable que este numerazo de aquí, este pedazo de números, ¿no? Lo paso a metros, que es multiplicar por 1000, ¿vale? Con factores de conversión, por supuesto. Luego pongo la fórmula de la velocidad, distancia entre tiempo. Despejo el tiempo, que es cambiando la c por incremento y el tiempo, ¿vale? Los cambio. Bueno, lo había hecho antes. ¿Dónde lo hice? Aquí, mirad, os lo expliqué aquí anteriormente, por pasos, ¿no? Pero como siempre es lo mismo, pues directamente lo he hecho, los he cambiado, ¿vale? Entonces ahora tenemos la distancia aquí, la velocidad aquí, la distancia va en metros, la velocidad en metros por segundo, entonces los segundos, acordad de una fracción y vosotros imaginaos 4 entre, yo qué sé, 5 medios. ¿Cómo hacéis esto? Para que entendáis que el segundo va arriba. Esto sería en matemáticas, ¿no? Sería 4 entre 5 medios, ¿verdad? Aquí hay un 1. Entonces, ¿esto cómo queda? 4 por 2 entre 5 por 1. ¿Veis que el 2 ha subido al numerador? O sea, el 2 sube al numerador, que es lo que os he hecho aquí. ¿Dónde está aquí? El ratón, aquí. ¿Lo veis? Y me da 4,99 por 10 elevado a 2 segundos, que son 499 segundos. Pasándolo a minutos para hacernos una idea mejor porque claro, en segundos nos cuesta más trabajo hacernos una idea, ¿no? Pero sin embargo, ya si nos dicen 8 minutos, 8,3 minutos, bueno, pues ya nos hacemos una idea, ¿no? 8 minutos que tarda en llegar la luz, en viajar desde el Sol a la Tierra. O sea, tú estás viendo un sol, si tú miras al sol, no lo hagáis porque os quemáis la retina, pero si tú miras al sol estás viendo el sol de hace 8,3 minutos. ¿Me estáis entendiendo? Es así. Y eso imaginaos, daos cuenta que eso es el sol que está cerquísima de nuestro planeta, pero imaginaos las estrellas, lo lejísimos que están. Pues estás viendo a lo mejor una estrella de hace 20.000 millones de años, ¿entendéis? Bueno, tanto no puede ser porque no es la edad del universo son 13.000 y pico de millones de años. Bueno, pues imagínate que estás viendo una estrella de hace miles de años. La luz de las estrellas que vemos por la noche es de hace miles de años o millones de años, ¿vale? A lo mejor esa estrella que estamos viendo ahora ya está muerta, ¿entendéis? La prueba es esta, que la luz, es que aunque la luz nos parece que viaja instantáneamente, no lo hace. La luz tarda un tiempo porque va a una velocidad, que es esta, que es la máxima que se puede alcanzar, según Einstein, la teoría de la relatividad de Einstein, ¿vale? Pero tarda un tiempo, poco, pero tarda, va muy rápido, pero tarda tiempo. Entonces, continuaríamos viendo el sol después de que desapareciera hasta las 12 y 8 minutos y un poquito más, y no sé cuántos segundos, ¿lo entendéis? Habría que calcularlo, vosotros sabéis pasar los 0,30, es muy fácil, 0,31 minutos, si yo lo multiplico por, hago factor de conversión, es muy fácil, un minuto, 60 segundos, ¿vale? Pues tenemos cuántos segundos son. Entonces sería, verás, muy fácil de hacer. Son 0,31 por 60, son 18,6 minutos. Perdón, segundos, ¿vale? Entonces estaríamos viendo el Sol hasta las 12 y 8 minutos y 18 y un poquito más de segundos. Y 18 segundos, ¿vale? Hasta después, aunque el Sol desapareciera. Tendríamos 8 minutos más de vida, ¿entendéis? Porque tarda la luz en llegar, ¿no? Bien, ok. Let's do the last exercise. It is, oops, where it is here. It is supposedly here. Wait a moment. If I pause, okay. I don't know what happens, but when I stop recording, I can move the these images. Okay, so I don't know. Okay, 22. How many kilometers separate us from our nearest star, Alpha Centauri? If it is 4.3 light years away. Okay? Currently, the fastest spaceship travels at only, imagine, okay, 17 kilometers per second. Whereas the light travels, see, at the speed of, at this speed. Can you imagine the difference between these two velocities? This is the fastest spaceship, la más rápida nave que tenemos. So imagine, and the light travels at this speed. This speed is 3 and 8 zeros. Sorry, kilometers. Okay. Imagine the difference between this number and this number. It is incredible. Okay. But however, it takes a time. So from the sun takes 8 minutes. So it takes a time. So um, how many kilometers separate us from our nearest star? Okay. So for example, we can do it. This is the distance traveled by the light in 1 year. Sorry. Sorry, perdón. Sorry. So the distance is 4.3 light years. So the light takes a time a time of 4.3 years. Okay, it is the same, and its speed is 3. Oh, sorry, and its speed is 3 times 8, 10 to, sorry, 3 times 10 to the power of 8 meters per second. So let's convert this to seconds. This is the time taken, 4.3 years, okay? And let's calculate it in meters or in kilometers, okay? So 1 year, remember, 1 year, sorry, 1 year is equal to 3,000, sorry, 365 days. 1 day is the same as 24 hours. 1 hour is equal to, if you want to, can do it directly. 1 hour is 3,600 seconds. So we have a total of, in scientific notation, of course, so 4.3 times 365 times 24 times 3,600. It is 1.36 times 10 to the power of 8. Yes, 8 seconds. Okay, so let's calculate the distance. Okay, so remember the formula. Oh, sorry. Oh, the distance divided by the time. In this case, we have to calculate the distance. C times the time. So, oh, sorry. I don't know what happens here. Sometimes C converts to 0. I don't know why. Okay, C is equal to 3 times 10 to the power of 8 multiplied by the time. Well, okay, let's write here meters per second. We cancel seconds, and at the end we have, as you can see, meters. Okay, meter. Let's do the operation. Multiply by 3 times 10 to the power of 8. It is 4.07 times 10 to the power of 16. Yes, 16 meters, or in kilometers, if you do conversion factors here, 1000 meters is equal to 1 kilometers, and it is equal, divided by 1000, is equal to 4.07 times 10 to the power of 13 kilometers. So let's write the number here, 07, and let's write many zeros. Okay, you can do it with your calculator if you can. I don't know if you will be able to do it, because the calculators, some of them normally, they don't normally have so many digits, okay? Tantos dígitos. So it is impossible. You have to use scientific notation. So it is 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, until here. Okay, so let's erase all these zeros. Come on. 0 and this 0. Okay, out. Okay. Oh, no, 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 no. Sorry. Okay, all these kilometers. Okay, kilometers. So it is thousands, millions, thousands of millions, billions. So it is 40.7 millions of kilometers away from us. Okay? Do you understand? It is a huge distance. And this distance is covered by light in 4.3 years. So imagine if we traveled, si viajáramos at the speed of light, at the speed of light, we will take at that speed 4.3 years. Okay, we will take through 4.3 years traveling at this speed. Okay, but the exercise tells us. Wait a moment. Yes. Oh, sorry. Yes. But let's say that it is section B of the exercise. Okay. Currently, actualmente, the fastest spaceship travels at this small velocity. How long would it take to get to that star? O sea, imaginaos, en español. Actualmente, la nave espacial más rápida viaja a 17 kilómetros por segundo. ¿Cuánto tiempo? Wait a moment. Wait a moment. I have to answer. Sorry. Sorry, I had to take to answer the call. Okay, we were speaking. Yes, we had to calculate the time taken by this spaceship traveling from here to Alpha Centauri. Okay, so the speed is now the formula is this one. B is equal to the distance divided by the time, because now we use B because it is not the light traveling, it is a spaceship. So we use B. Okay, we have to calculate the time. So the time is, if we solve this, it is the distance divided by the speed of light. Okay, sorry, the speed of light. Oh my gosh, no, it is the velocity. Okay, this speed is in the international system is 1 kilometer is equal to 1000. Sorry, by my handwriting, it is awful. Yes, so it is 17,000 meters per second. Okay, 17,000 metros por segundo. Okay, so the distance is here. Okay, in meters. We calculate before the distance. So the distance is 4.07 times 10 to the power of 16 meters. Okay, and the speed is 17,000 meters per second. So remember, we did it before. So the seconds go to the numerator, and we have to do this operation. We have 4.07 times 10 to the power of 16 meters divided by 17,000 is equal to the time is equal to 2.39 times 10 to the power of 12 seconds. Okay, all these seconds. So now if we want to have an idea of how much time this is, let's convert it to years. Okay, so remember to convert, for converting these 2 years, we have to do the inverse conversion factor to this one, okay? On the other way around. So we have to say 3,600 seconds is 1 hour, okay? And 20 hours is equal to 1 day. And 365 days is 1 year, okay? So that we can, yes, 10 days and days. So we have to divide by 3,600, divide again by 24, and divide again by 360 that. So it is 7.59 times 10 to the power of 4 years, and it is it is a very huge, incredibly big number of years. It is 7,590 years. It's a long time. So the spaceship, this our fastest spaceship, would take to this 7,590 years to travel to Alpha Centauri, ¿ok? 7.590 años en llegar a Alpha Centauro, que es la estrella más cercana a esta velocidad, claro. La luz tarda 4 años, 4,3 años, pero esa nave nuestra, la más rápida, tardaría 7.590 años, ¿ok? Now, for next day, we have finished, okay? Now, let's say let's say we have finished all the concepts, all the matter we have to do. And for next day, I want you to do, maybe tomorrow, I don't know, I think maybe for next week, I want you to do exercises. Pay attention, okay? Exercises 8, 9, okay? 8 and 9 of page, I will take note of it. 8 and 9, page 154. Okay, these two exercises. What else? What more? Yes. Exercise 15, 15, 16. This is for springs, okay? Springs, muelles. This is for friction, okay? This is like a general review of everything, okay? 17, 17. This is for next week, okay? This is the task for next week. 17, and I don't know if, yes, yes, wait a moment. This one, 12, 12, 13. I will correct them next week, okay? 13, um, and just it, okay? And that's it, okay? That's it. Yes, all these exercises. This is for of page number 155. Okay, for next week. I will correct it by the end of the week, or maybe Thursday or Wednesday, or I don't know. Because the next week, the week after next week, we will do an activity for evaluating this. For example, let's say this is next week, okay? So during this week, the marks have to be on Rayuela by this time. This is the deadline for uh, writing, yes, or recording the marks on Rayuela. So let's think, for example, that this day, 8, the 8th of June, the 8th of June, we will have an activity for um, assessing, evaluating forces, okay? Only forces. So study, because we can't do it this day because I need time to correct all the exams. You are 48 between both groups, okay? You are 48, so I need time for correct the exams, the activity, sorry. So this day, the 8th of June, you will take an exam, no, I can say an exam, I can't say an exam. You will have an activity for evaluating forces. Unfortunately, we won't have the time for doing the next lesson, which is energy. I hope you will do it next year, but it would have been interesting that you have learned something about energy, but we don't have the time. So I'm sorry, but we will stop here. But don't forget, this day, wait a moment, this day, the 8th of June, you will take an activity, you will do an activity, a task for evaluating this unit, okay? The forces, only forces. Just from, wait a moment, I will tell you from the page from which you have to study. Wait a moment, because internet is slow here today. Wait, force of gravity, forces, wait. It is because this unit is like 2 units, normal units, so it is very long. Forces from here. The concept of force, because this is kinematics, do you remember? So from here, you have to study all, you have to watch the videos and you have to study the exercises we have done, the theory, you have to know this, okay? Study, these are the theories of forces, the composition of forces, remember the formations, types of bodies, okay, Hooke's law, mm, um, the variation of state of motion. You have to know how to do this type of exercises here. Yes, and this is all. Yeah. Force of gravity. Um, yes, and this is the difference between mass, weight. It is really important. Yes, and this one. Okay, the distance is in the universe. So this is all for today. Next week I will correct all the exercises I assigned to you before. Okay, so see you and have a nice time.